So let's talk about theory. So there is force and velocity, and both of them are vector quantities, which means they have both sides and directions. So velocity is the speed of an object in a specific direction, while force is what causes an object to move, stop, or change the directions. Gravity is a force that pulls objects toward each other, and on Earth, it gives object weight. So there is weight. So weight is simply the gravitational force acting on an object. So another important force is the normal force, which is perpendicular to the surface on the object rests on. So for an object on a flat surface, the normal force is equal in the size to the object weight. So finally, let's talk about the frictions. So friction is the force that resists the motion between the two surfaces in one contact. So there are two types of friction. So the first one is static and the second one is the kinetic. So static friction.
So this is the apparatus that we use for this experiment, and also this is the procedure. Okay, here this is the rubber surface data, and here this is a graph of static friction force versus normal force for rubber, and this is the data for the non-rubber surface. Okay, so here is the result and the data that we got from this experiment. So here is the graph of static friction force versus normal force for a rubber surface, and also we got the graph of static friction force versus normal force for non-rubber surface. Okay, based on these two graphs, we got a linear graph, and also based from these two graphs, we can find the coefficient by using the gradient from the graph. So that you guys can see, the coefficient from rubber surface is more higher than coefficient from a non-rubber surface. Why this has happened? This has happened because there is a friction between the rubber and the wooden surface, which causes the rubber surface to have a higher coefficient more than non-rubber surface. Based on this experiment, the objective is to determine the coefficient of static friction of different surface. The normal force and static friction force is increased, easy because static friction is the force that prevents the object from moving when an external force tries to push or pull it.
A source of errors. First, inconsistent pulling force. If the spring scale is not pulled smoothly or too fast, it may give inaccurate readings of the static friction force. It will leading to errors in measuring. To avoid this, pull the spring scale slowly and steadily and repeat the measurement several times to get average value. And for the second one, uneven distribution of mass on the block. If mass are not centered, they may tilt the block and reduce proper surface contact. To avoid this, place mass directly in the center of the wooden block to maintain balance. And lastly, parallax error when reading the spring scale. Usually we will make a mistake when we're reading the spring scale in a wrong angle, and it will give us the incorrect result. To avoid this, make sure to always view the spring scale on eye level to avoid misreading.
Next is question. Question 1. How can anti-lock brake stop a car in a shorter distance than regular brake? Anti-lock brake will pump the brake so that the tire do not experience kinetic friction but steady, which in turn slow the car faster and in a shorter distance. Question 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient or static friction? From the experiment, the rubber surface toward the floor has the highest coefficient because there is friction between the rubber and the surface. To the rod of the surface, the greater the friction. Thus, as the coefficient of static friction is determined by the frictional resistive force. Question 3. As the mass begins to slide, Does it move smoothly or does it undergo stop and go motion? Explain motion. It does move, stop and go motion with to the mass is a greater weight which causes bigger frictional force as the bigger frictional move downward. The mass cannot go smoothly to the act of friction between surfaces become more greater. Last is conclusion. The experiment successfully demonstrates the relationship between the normal force and the static frictional force acting on the object. As the normal force increased by adding more mass to the wooden block, the static frictional force also increased proportionally. This supports the theory that static friction depends directly on the normal force.